I'm CK. Today we've got one that I think will be pretty much fun. It's a LED owl with touch control. So we'll put it together, see if we learn anything, like how they're setting up the touch control, and get some good solder practice, and I hope you enjoy the video. The bag, I picked this up from Amazon. IC Soldering Learning Kit, Touch Control Owl Light Soldering Practice Kit with 3 lighting modes, brightness adjustment, owl-shaped LED light soldering kit for school students, STEM education, and it's new. Let's get the bag open. Pull the circuit board out. And as you can see, let me zoom in a little bit. Coming in a little bit. And here is the owl. It's got LEDs all around, all around, all around. So a lot of good LED soldering, all through hole. And then it's got a touch me here, which is probably some kind of pad or other. We'll figure that out when we look at the rest of the parts. On the back, we've got a capacitor, another cap, 2 transistors, some resistors, a couple more caps, 5-volt power in, another transistor here, that's a surface mount one, and then one surface mount IC. So there is some surface mount in here. We'll look that IC up when we get to it. There may be a piece of paper. Here's the piece of paper. So SOP 8JL7010S. I'll look that up in the interval. And it all looks good. Electrolytic capacitor, good component list here. Then good instructions, taking you very step-by-step through installing the surface mount controller, which is good. Some resistors, some whatever, and all that. That all looks good. Nothing on the back. Let's dump the parts out. Another USB cable. This is USB-C on one end, because this is what this uses, which is good. Since everything except my Apple TV remote is now USB-C. Okay, we got a bunch of lights here. We've got the transistor, and here is the IC that is apparently for the touch control. There's the resistors, here's the USB power socket, some screws and spacers to stand it up when we're done. Let's turn on one of these lights. I'll use my meter in continuity mode, which sends a little bit of power through the probes, and that is generally enough power to light up an LED, so we can take a look at it. Oh, they're bright white. Okay. Hopefully they're all the same. Actually, let me take a look at the data sheet to see if they are all the same colors. They are all white LEDs. Okay. So that's it. Looks pretty straightforward. Oh, it does have a memory function. Huh. Oh, in case of a constant power supply. So that's not long-term memory. It's just power-on memory. So I'm looking at this trying to see. Oh, I see. I wish they had a schematic here. It would work better for me. I think we're going to have to look at the JL7010 chip and see how it goes, because it looks like you touch the leads of the resistor, but I'm not really sure. It's acting almost like you touched just here, but I don't... We'll figure it out. I'm sorry, I'm just rambling in my head. So I'll get this soldering iron heated up, and we'll put this thing together. Well, I looked up this 7010 chip, JL7, and it's called a touch chip, but I can't find an English language version of the datasheet. I mean, here's the Chinese one. You can see the touchpad goes into T1, and then that goes out to this LED, and this and SoC1 and SoC2 go over to theoretically other things to trigger, but I don't have any more information than that. That's very unusual. I can usually find an English language datasheet for any chip, but not for this one. So the first thing we're going to do is we're going to do U1, which is the touch chip. And I'm going to get my standard set of things to do surface mount with. First we'll take the chip out of its packaging with this pair of tweezers. Drop it on the ground here. Look to make sure we've got a good indicator on the chip for its orientation. Yeah, we do. We've got a dot right here. You may not be able to see it. I'll probably zoom in a little bit. It's got a dot on it to indicate where pin 1 is, which also has a dot on the circuit board. Let me zoom in just so you can see really close what we're doing. And I'm going to go to manual focus here so we don't lose. There we go. Now we're going to do surface mount by hand. So I'm going to get some chip quick, and that's flux. And my thinnest solder, my point is 0.25 or 2.1. What is it? 2.5 or 2.1? 2.5. From MG Chemical out of Canada. We'll see if we need to use that. I think we probably will. So what we're going to do is we're going to put solder on one pad. I like using this pad, the upper right one. The instruction guide says randomly choose a pad, and you can certainly do that. Now I'm going to move the chip over here, and then I'm going to make sure I'm still in the shot, and I still am. I'm going to get my head in the shot for a minute because I'm lining up all the pins, so when I get things locked in here, and I'm reheating that solder pad that I put on there, and the chip is now firmly affixed, so I can do what I need to do next. And the next thing I'm going to do, because these pins are somewhat close together, is I'm going to get a little dab of Chip Quick, excuse me, and dab it on those pins, because this will keep the solder from flowing between the pins as I put it on. And you'll notice I'm doing the side opposite the side that I already soldered one pin with, just so I don't knock things around or reheat that one and have everything go to heck, because it won't come back for me. Now, I put the tip of my soldering iron between the legs and just put the solder in there. As you can see, it's flowing in very, very smoothly. So that's those 4 pins. Now I'll use the rest of the Chip Quick that I have on my pointy thing and do this side. And while I do this, I'm going to be putting a little bit more solder on the leg or pin I already did. Oops, bridged that one. Gonna have to put a little more chip quick on there because I did bridge it. Didn't have quite enough on there. I mean, worst comes to worst, I'll try and solder suck it off, but I should be able to get it off with a little more flux in there. There we go, got it all off. Now the other chip is a regular transistor and the pins are far enough away that I won't need to put more flux on there. And then we go over and do the next little chip. And so the same thing, we'll put it out of its packaging. Let me get you two in the center of the camera shot. And there it is. And we will, once again, tin the big pad here. This one's much easier than the one we just did. Where did I put my tweezers? There I did. Because these pins are very spaced very far apart. I'm getting my head in the shot again so I can get this lined up right. And now I'll reheat this pad. Yeah. Didn't get it quite right because I was holding the tweezers a little too high. There we go. Now it just sank in. It's a little crooked, but I think I can manage. And because the pins are as far apart as they are compared to the other chip, I won't need flux for that, as I mentioned. Just draw that in like that. Draw that one in like that. And draw that one in like that. Make sure they're fully affixed. And that is it for the hardest part, which is the surface mount chips. So as you can see, not too difficult. Of course, I've done it a lot. If you're just starting out, this is your first surface mount, do this one first, and then do the touch chip, and get yourself some flux. This little tub of flux costs $20 or $30, I forget which, might even have been more. But I've been using it for a year and barely have used up any of it, so you're not going to run out of flux anytime soon. One container will last you a long time. Now we're going to do the 1K resistors, and again, since there's nothing on the board to tell you where they go, you have to go with, I'm double checking the resistance on my meter, yeah, 0.997. You have to just look. R1, R2, and R3. I'm going to back the camera off a little bit more so we can stay. You don't have to be too carried away. I'm still in manual focus, so I don't know how that's going to look. That's R1. R2, and I think R3 is more widely or wider spaced than the others, so I'm going to give like a 1.5 millimeters out from the body on the bend. If I'm wrong, I can just snug it back in, but if I'm right, why is this not going through there? There it goes. Why is that not going through there? There it goes. So we'll talk about that in a second. Let me solder these fellas. Let me go back out of autofocus because I want to show some stuff. Hold on. So on this one, which is on its little beak, there are leads coming away from it coming to this, or traces. But on this side, there's no connections. So when you touch it, you're actually bridging that resistor. That's what is going to be triggering the touch sensing. Now we'll do the other two resistors. Where did they go? Here they are. These should be 10Ks, and they look like 10Ks. We'll double check them just to be sure. 10.4. R4 and R5. I'm not going to solder those right now. Now we're going to get our 104 as our 1/10 of a microfarad caps. Decoupling caps, that's not it. Decoupling caps for the chip. That's a 104. These provide, again, you can go look it up, read about it online, either look at videos or read about it. This goes in C2. These buffer power a little bit going to the ICs. They're providing a little reserve of power in case your voltage fluctuates going to the chip so it doesn't glitch out on you. And they also smooth out, take out some noise, theoretically. Now the 106 goes at C3. But again, learning about decoupling caps is an important part of learning about how to do work with integrated circuits, because almost every IC requires a decoupling cap. It's in their data sheet. And I'm going to do the 2 transistors. Then we'll start soldering things down. And they're both the same, 8050s. And all you have to do is match the flat side of the transistor with the mark on the board showing where the flat side is. So that's pretty straightforward. And then he would like us to do, actually I'm going to solder these bits and pieces on right now. Clean up the backside a little bit. Now we'll put the power connector on. And it will go here on the back, and the pins are offset a little bit, so you should be able to see how it goes on without too much difficulty. Oops. Even though it's not as tall as the 106 decoupling cap I put on. So let me get a little piece of foam here. Put that on there like so, and set this down like that, and that keeps it in place. And I'm going to solder one leg, one of the support legs. If I can pick up my gosh darn solder. So that's in place. Let me take a look, and it's a little tilted. So what I'm going to do is I'm going to push on it with my index finger on one side of the board and reheat that. There we go. It clicked into place. Now I can do the other leads. We only are pulling up 2 pins from the power connector because it's a power connector. We don't need the 2 data pins. Hope that works. It's very short leads on that connector. And it is still crooked, huh? Oh well. We'll see. I think that's good, but I may have to rework that later. Now we'll do the electrolytic caps. Where did the electrolytic caps go? Oh, there's only one. Okay, good. I didn't look at the board. So there's a shaded spot which shows where the gray line goes, and there's a square pad which shows where the positive side is, which is the long lead. So you have two ways to identify the polarity of the capacitor. Let me clip those leads off. Now, you got 60, count them, 60 LEDs. And we don't have plus signs or minus signs on the board. We don't have a circle with a flat spot indicating where the cathode side goes, but we are putting the LEDs together where the long leg goes in the square hole. So let me do one. I'm going to do this one right on the bottom, double checking my lead length, and show you how I'm going to be doing these. So I'm going to, because I want this all to look somewhat neat, or as neat as an impatient person like me can do. Oops, and I'm putting it on backwards, because you want to put it, and this side does have the shaded area showing where the flat spot goes. I was wrong because I was looking at the wrong side. Again, you want this on the side that says touch me. So we will solder one lead, and to make sure it's all flat and neat, do the same thing, push on it with my index finger, reheat that solder pad, and there we go. Now the only thing I have to do is do that 59 more times, and then do the, of course, solder the other leg, but we'll get to that. So again, I mean, there's not much more to say about this, so I'm gonna speed up the playback, probably cut some of it out, and we'll put all the LEDs on in fast motion. And all the LEDs are on. I think I got them all on the right way. One thing to always think about when you're doing a repetitive task like putting these 60 LEDs in, you can get kind of zoned out and you'll put them in backwards. Just every 5 or 6 LEDs, just lift your head, look around, and say, okay, let me get back to putting them all in the right way. I got most of them straight. I didn't really care all that much. They also gave me 3 spare LEDs in case anything's burnt out. You could test all of them before you install them. I just didn't care that much. Sorry. But we'll see if they all work. Now I'm going to put this screw and one of the brass standoffs on, and then this screw and the other brass standoff, and that makes it stand up. Well, kinda. It's since it doesn't have any angle, it's very kind of flaky. You may want to do something different with that if you're going to play with this. Now let me turn off this light, and I'll plug in the power cord. And where is my USB connector there? And we'll plug it in. Don't know if it'll come on or not. Not yet. So when you touch it, based on what I see on the data sheet, since we don't actually have a schematic for this, every time you touch it, it'll turn on one or more of the pins, output pins, and I think they feed the 3 transistors. So there should be 4. Oh, And I just touched them on the back. That's the one problem. Okay, so it works. And let's see, we've got all the LEDs in correctly and lit up. There we go. So I'll touch here, one touch. Okay, so that's the off position. Then I touch it again, and it gives me the eyes. Touch it again, it gives me the outer ring with the ears. Touch it again, and they're all on. So that's the way this works. And again, we saw from the data sheet how the chip might work. If anybody can find an English language version of the JL7010S chip, go ahead and put the link to it in a comment. I will make sure I approve that comment. YouTube makes us approve comments with links in them just to make sure people aren't spamming. So we can learn from it. I wish they had a schematic for this too, but they don't. So that's the way it looks. Turn it to the side there so the side camera can have a look. And it's a fun little kit, some good surface mount practice, and a lot of regular through-hole practice. And I hope you enjoyed the video.